Welcome to Brain Vision.
So first, let's solve for the case when the switches are both open. So we have both switches open. So in this case, the circuit is a simple series circuit. So now let's apply Kirchhoff's loop rule to find the current in that case. So we have voltage minus I times the equivalent resistance, and since this is a series circuit, so the equivalent resistance will be sum of the other resistances that are connected, other resistors that are connected in series, that is equal to 0. Now from here we can find I to be equal to 6 volt over 80 ohms, and that comes out to be 0.075 ampere. So this is the current for the case when the switches are both open. Now let's consider the case when both the switches are closed. So in this case, the 20 ohm resistor will be in parallel with R. So let me just write all in series here, and if the switches are closed, then the 20 ohm resistor will be parallel with R. Now let's apply Kirchhoff's loop rule to the outer loop of the circuit, and with the 20 ohm resistor having the current found previously. So the 20 ohm resistor will have a current equal to 0.075 ampere, and we will use this current to solve for Kirchhoff's loop rule for the outer loop of the circuit. So the equation will be 6 volt minus, if say let's call it I1. So we have minus I1 20 ohm, then we have minus I2 50 ohm, and this will be equal to 0. So from here we can find I2 using by solving this equation and plugging the value of I1 from here, you can find I2, which comes out to be equal to 0.09 ampere. So this is the current for the parallel combination when the switches are both closed. Now, since 0. Let me just pick another color for that. So since 0.075 ampere, which is I1, flows in the 20 ohm resistor, therefore we have the remaining current. So it's like I2 minus I1. So this amount of current should flow through resistor R, and I2 minus I1, if you calculate that comes out to be equal to 0.015 ampere. So this much amount of current flows through the resistor, flows in capital R. Now the voltage drops across capital R, and the 20 ohm resistor should be the same for the second case, because both of these are in parallel. So remember that we are still continuing to solve for the second case when the switches are closed and the 20 ohm resistor is therefore in parallel with capital R. Now the voltage drop across the 20 ohm resistor is equal to voltage drop across R. And by Ohm's law, we can write this to be, so this will be the current times the resistor for the 20 ohm resistor. So we have current, which is I1, times resistor, which is 20 ohm, and this should be equal to IR, which is 0.015 ampere times R, and R is the value that we need to find. So R will be equal to I1 over IR times 20 ohm. Now if you plug the values of I1 and IR, which is basically I1 is 0.075 ampere as found here, the notation is also there, and IR is the current flowing through R, capital R. So we plug these two values in this equation and we find the resistor to have a resistance of 100 ohms.